Hello friends, I welcome you in lecture number 36 on hypothesis testing. In this lecture, we are going to discuss about hypothesis test for the population correlation coefficient or t-test for the correlation coefficient. We have estimated certain parameters of the population before this lecture. We have seen in earlier lectures that how we can estimate population mean using the sample mean. Similarly, we have seen how we can estimate variance using the sample variance. We have also seen how to estimate population proportion using sample proportion. So we have conducted hypothesis tests for population mean, population variance, population proportion using the corresponding sample statistic. Now we are going to estimate population correlation coefficient denoted by rho using sample correlation coefficient denoted by R. So here our aim is to estimate the population correlation coefficient using sample correlation coefficient. Now whenever we are talking about correlation, we always have two variables, say capital X and capital Y are the two variables under consideration. So in this case, our population will be a bivariate population and we want to check whether there is any correlation between these two variables. So for that, the corresponding measure is population correlation coefficient. But sometimes it is not comfortable or it is not possible to find out this correlation coefficient for population. For population, we have to find out values of X and Y for each and every object under consideration. So sometimes if it is not possible or it is not convenient, then we are using sample correlation coefficient to draw inferences about population correlation coefficient. So we can take a sample from the bivariate population and we can calculate sample correlation coefficient, and from this we can take the estimate for population correlation coefficient. We have discussed in the lectures of basic statistics that how to calculate sample correlation coefficient or correlation coefficient. So if you are not familiar with correlation or correlation coefficients, you can watch my lectures on correlation coefficients. Now here we are going to apply t distribution or t statistic, and here t test will be applicable for the test statistic. So the formula for test statistic is t equal to R times, R means sample correlation coefficient, times square root of n minus 2 divided by 1 minus R square, where R is the sample correlation coefficient, n is the number of observations in the sample. There will be n observations for variable X and n observations for variable Y, or we can say that there will be n pairs for variables X and Y. So we will calculate value of test statistic using this formula, and this formula uses the assumption that null hypothesis is correct, that is population correlation coefficient is 0. We will consider null hypothesis as rho equal to 0, that is there is no correlation between variables X and Y in the population, and alternative hypothesis will be rho is different from 0, that is there is a correlation between X and Y in the population. So if we assume that this null hypothesis is correct, then the formula for test statistic is given by this. In general, the formula for test statistic is R minus rho times square root of n minus 2 divided by square root of 1 minus r square. But if we assume that null hypothesis is true and then we have rho equal to 0, so here we put rho equal to 0 and we obtain this formula for test statistic. And if we are considering our population as bivariate normal population, that means we take the assumption that this x and y are following normal distribution, or x and y are normal random variables, then our population is called bivariate normal population. To apply this formula, the assumption is that our population is bivariate normal population, and under that assumption this is going to follow t distribution with degrees of freedom equal to n minus 2. And we are familiar with the t distribution. It is similar to the normal distribution. Its graph is bell-shaped curve, similarly as in the case of normal distribution. So graph of t distribution is also a symmetric bell-shaped curve, and we are considering values of t on horizontal axis. To find out critical values, we will require level of significance. If it is not given, then we will consider alpha equal to 0.05, and with alpha level of significance and given degrees of freedom, we will find out value of critical value of this t distribution, and then we will compare these two calculated value of test statistic and critical value. Now here null hypothesis is that rho equal to 0, and alternative hypothesis is that rho is not equal to 0. So here we have two-tailed test, therefore we will divide level of significance into two equal values of alpha by 2. So this area alpha is divided into two equal areas having alpha by 2 value. Therefore this critical point is denoted by t alpha by 2. This critical point is denoted by minus t alpha by 2, and the region to the right of this critical value and to the left of this critical value is rejection region, and this region between these 2 points is non-rejection region. So using this rejection regions, we can take the decision that whether we should reject the null hypothesis or we are not able to reject the null hypothesis. This is also rejection region. So this is very simple hypothesis test for population correlation coefficient. We can again summarize. Our null hypothesis is that population correlation coefficient is 0, that is the two variables are not correlated, or two variables are not associated, or there is no correlation or association between two variables. And alternative hypothesis is that population correlation coefficient is different from 0, that is there is some correlation between two variables. And if we assume that null hypothesis is true, then test statistic is given by t equal to r times square root of n minus 2 divided by square root of 1 minus r square. So we will remember this formula for test statistic for this test for correlation coefficient. And after that this formula or this random variable t defined in this way has the t distribution with n minus 2 degrees of freedom. And as I discussed, we would reject the null hypothesis if t is greater than t alpha by 2 or t is less than minus t alpha by 2. So as I discussed, the region to the left of minus T alpha by 2, region to the right of T alpha by 2 are rejection regions, and region in between is non-rejection region. And to apply this formula for test statistic, we assume that the joint distribution of two variables under consideration is the bivariate normal distribution. Whatever variables we are considering, say x and y, both follow normal distribution. Therefore, their joint distribution is also a bivariate normal distribution. So, with this assumption, we can apply this test. Now, we discuss this example on this hypothesis test on this correlation coefficient, and this question was asked in summer 2021 as well as winter 2021 GTU exam. Same question was asked in both the exams. A random sample of size 15 from a bivariate normal population gave correlation coefficient R equal to 0.5. Does this indicate the existence of correlation in the population? Choose level of significance as 0.05 and table value is given 2.160 for 13 degrees of freedom and alpha by 2, that is 0.05 by 2, which is T 0.025. This is already given, so you need not use table. This is 2.160. So here we are given sample size equal to 15, and they have calculated correlation coefficient for that sample, and according to their calculation, value of sample correlation coefficient is 0.5, and from this we have to answer this question: does this indicate the existence of correlation in the population? From sample we can say that there is a correlation between two variables. Now we have to test whether there is existence of correlation in the population, that is whether population correlation coefficient is 0 or non-zero, or if it is different from 0. So the question is, does this indicate the existence of correlation in the population? That means whether this indicate that this population correlation coefficient is also different from 0, or it is not significantly equal to 0. So we start by considering the null hypothesis. Null hypothesis is always that population correlation coefficient is 0. Alternative hypothesis is opposite of this, rho is non-zero. Level of significance given is 0.05, and it is given in the question that they are considering a sample from a bivariate normal population. So because this population is normal, we can apply this formula for test statistic: T equal to R times square root of n minus 2 over 1 minus R square. So using that formula, we have to calculate value of test statistic 1 minus R square. Degrees of freedom are n minus 2, value of sample size is 15, so we have 13 degrees of freedom. So I have calculated this value, as well as I have obtained this using table also. This is already given, but we will see using table also. Suppose it is not given, then how to use T distribution table to find out critical value. I have written all these things here systematically. You should write your answer in this way. First, write down the null hypothesis, rho equal to 0. That means there is no correlation between the two variables in the population. Alternative hypothesis is rho is different from 0. That is, there is a correlation in the population. Level of significance is 0.05, Now we calculate value of test statistic. Sample correlation coefficient is 0.5, so I substitute 0.5 here. Sample size is 15, and after doing all these calculations using my scientific calculator, I obtained calculated value of test statistic as 2.0818. Now to decide critical regions, first I have to decide degrees of freedom. So there are n-2 degrees of freedom for this t test. Therefore we have 13 degrees of freedom. Alpha is 0.05, therefore alpha by 2 is 0.025 and 13 degrees of freedom. So we have to use t distribution table for alpha equal to 0.025 and 13 degrees of freedom. So let me open my t distribution table. Just a minute, it will take few seconds. We are interested in the value of t distribution or t random variable for alpha equal to 0.025 and 13 degrees of freedom. So these are the statistical tables, and we are interested in t distribution table. Here you can see the column on the left has degrees of freedom, and we are having two tail test, and level of significance is 5%. And if we divide into two equal areas, we have 2.5%. So this corresponds to 5% level of significance for two tail test and 2.5% level of significance for one tail test. Degrees of freedom are 13, so I have to look in this row, and here I have to look below this column, and I have to take intersecting point of this row and this column, and you can see our value is 2.160. Value of test statistic with t 0.025 and 13 degrees of freedom is 2.160, and it is already given in the question, so you don't have to use a table here, but this is just for understanding. If you are not given table value in the question, then you can find out table value in this way. And because t distribution has symmetric bell shaped curve, minus t alpha by 2 is minus 2.160. Okay, let me sketch the graph of this t distribution just to explain the rejection regions. We are familiar with the graph of t distribution. It is a symmetric bell shaped curve like normal distribution. So suppose this is the graph of t distribution, and our level of significance is 0.05, but because we have two-tailed test, we are dividing level of significance into two equal areas. So this is alpha by 2, which is 0.025. This point is t suffix 0.025. Here somewhere we have t equal to 0 minus t suffix 0.025, and these two are rejection regions. These two areas are 0.025 and both are rejection regions, and in the middle we have non-rejection region. And we find using table that this value is 2.160 for 13 degrees of freedom, and due to symmetry this is minus 2.160. Now we have to check what is test statistic value. What is the location of test statistic value? It is 2.0818. 2.0818 is less than this value, so it might be somewhere here. Suppose this is the value 2.0818. This is value of test statistic, calculated value of test statistic, and we can see it is in non-rejection region. because it is in between these two critical values. If it is to the right of this critical value or to the left of this critical value, then we are in rejection region, but it is in between these two critical values, therefore we are in non-rejection region. That means our decision is that we fail to reject the null hypothesis. So I have written here this minus 2.160 is less than 2.0818, calculated value of Statistic is less than 2.160, therefore we fail to reject the null hypothesis. And what is null hypothesis? Null hypothesis is that population correlation coefficient is 0. So we can say that the sample data does not indicate the existence of correlation in the population. If we are able to reject the null hypothesis, that means we can say that rho is not equal to 0. But here we are not able to reject the null hypothesis. Null hypothesis is that there is no correlation. So therefore we can write our conclusion or answer in this way: the sample data does not indicate the existence of correlation in the population, or in simple words, the sample data does not indicate that population correlation coefficient is non-zero, or the sample data does not indicate the existence of correlation in the population. This figure is just for understanding. It is not compulsory to sketch the figure in your answer when you are writing the exam, but this is just for understanding that how we are considering, how we are taking the decision by comparing the calculated value of Statistic with critical values. So this is very simple test for correlation coefficient. It is known as t-test for correlation coefficient or hypothesis test for correlation coefficient, and this Statistic formula must be kept in mind. It is t equal to r times square root of n minus 2 divided by 1 minus r square, provided that null hypothesis is rho equal to 0 and this is correct. We assume that null hypothesis is correct and we are testing this null hypothesis using this Statistic formula, and this follows t distribution with n minus 2 degrees of freedom at given level of significance. So this is all about this session. I hope you like this lecture. Thanks for watching.